When Neil Armstrong took those first steps on the moon, it felt like the absolute peak of the 20th century space race. But what happened after that is, in a way, even more fascinating. The paths to exploring the moon and Mars split apart, took some wild twists and turns, and now they're finally coming back together for one single audacious goal. So let's trace this incredible 50-year journey from one giant leap to the next.
All right, here's what we're going to cover. We'll start with how the Apollo era created two totally different approaches to space exploration. Then we'll see how robots took over and set their sights on Mars. After that, we'll dive into the new global race back to the moon. We'll also break down why you can't explore these two worlds the same way, and finally, how it's all coming together for humanity's next giant leap.
So let's rewind back to those first historic footsteps on the lunar surface. The echo from that one moment sent space exploration shooting off into two very, very different directions.
What Apollo accomplished was just monumental. Between 1969 and 1972, the U.S. landed on the moon 6 separate times. They put 12 humans on another world. And that plaque they left behind, it says it all. This wasn't just for one country. This was a moment for everyone.
But this is where the story splits. While America was going all in on human triumph, sending astronauts, building incredible machines like the lunar roving vehicle, the Soviet Union was playing a completely different game. They were becoming masters of robotics. They pulled off the first ever automated sample return and put the first remote-controlled rovers on the moon. So you had these two philosophies, right? Human-led versus robotic pioneers. And that would define space exploration for decades.
So, after the last Apollo astronaut came home and the final Soviet robot touched down in 1976, the moon just went quiet. The spotlight shifted, and a whole new generation of explorers, robotic explorers, started to wake up on Mars. And this timeline just lays it all out, doesn't it? The very same year the moon went dark, NASA's Viking landers touched down on Mars to start the science. Then, after a bit of a gap, Mars Pathfinder and its little rover, Sojourner, showed that, hey, this roving thing can actually work. But then in 2004, bam! Spirit and Opportunity arrived, and the game was changed forever.
Just look at this evolution. It is incredible. We went from Sojourner, which is basically a microwave-sized tech demo that barely traveled 100 meters, all the way to Perseverance, a 1-ton, car-sized, nuclear-powered science lab, and you can see the ambition grow with each one. It went from, can we do this? To let's follow the water, then to, was Mars ever habitable? And now to, let's actively look for signs of ancient life.
And the success of these robots was just mind-blowing. Take Opportunity. It was designed to last for 90 days. Instead, it explored Mars for nearly 15 years. It drove over 45 kilometers and sent back proof that ancient Mars was a wet world and maybe, just maybe, a habitable one.
So with all this incredible Mars exploration happening, you'd be forgiven for thinking the moon was just a case of been there, done that. But what if it wasn't? What if our closest neighbor was hiding a massive, game-changing secret right under our noses?
And this was it. This was the secret. In 2009, India's Chandrayaan-1 mission found something amazing. It discovered that the moon was not the bone-dry desert we all thought it was. There were water molecules locked up in the minerals, everywhere. And that one discovery, well, it changed everything. It completely reignited the world's desire to go back to the moon.
And that brings us to today, and to the new global race back to the moon. A race that looks totally different from the first one.
Leading the charge in many ways has been China. Their Chang'e program has been an absolute masterclass in planning and execution. They've just been ticking off one historic first after another. The first soft landing in almost 40 years, the first ever landing on the far side of the moon, and 2 successful sample return missions, one of them from the far side. They have, without a doubt, established themselves as a major lunar power.
But here's the cool part. It's not just China. This is a truly global effort now. India made history, becoming the first country to land near the lunar South Pole. Japan pulled off an unbelievably precise pinpoint landing. And in 2024, for the very first time, a private company, Intuitive Machines, successfully landed on the moon. This is a whole new era.
Okay, but let's be totally clear about something. This is not easy. Far from it. This number is pretty sobering. For every incredible success story, there's a heartbreaking failure. Missions from multiple countries and companies have been lost. We're looking at a failure rate of more than half in this new era. It's a brutal reminder that landing on the moon is still one of the hardest things humans can do.
So, we have all this amazing activity happening at both the moon and Mars. But you can't just use the same strategy for both. Why?
Well, because they are two totally different worlds that play by completely different rules.
First up, atmosphere. The moon basically has none, which means to land it's all about firing your rockets at just the right time. But Mars has this thin atmosphere that's a real double-edged sword. It's thick enough to burn you up on entry, so you need a heavy heat shield, but it's too thin for a parachute to slow you down enough on its own. And yet, that same thin air is exactly what allowed the Ingenuity helicopter to fly.
And then there's the sheer distance. The moon is right next door, a 3-day trip. You can have a conversation with a rover there almost in real time. But Mars? That's a grueling 6 to 9 month journey one way. And the communication lag can be up to 20 minutes. You can't just joystick a rover around. That's why Mars rovers have to be so smart. They have to be autonomous geologists, making their own decisions.
So all of this really shapes the main goals for each world. The moon has become our ultimate proving ground. It's a place close to home where we can test out all the technologies and procedures we're going to need for deep space. Mars, on the other hand, is this epic scientific detective story, a patient, methodical search for clues that life may have existed there once. Which brings us to our final section, and this is where it all comes together. For 50 years, these two paths of exploration, Moon and Mars, they pretty much ran in parallel. But now, finally, they are converging on one single incredible goal.
And this is it. It's the Moon to Mars strategy, and it's a pretty clear step-by-step plan. Step 1, the Artemis program returns humans to the moon, but this time to stay. Step 2, build a small space station in lunar orbit called Gateway to act as a staging point. Step 3, and this is crucial, learn to live off the land. Use resources like that lunar water ice to make breathable air and rocket fuel. And then, Step 4, take everything we've learned, all the technology, all the experience, and apply it to taking the next giant leap to Mars.
And while we're getting ready for humans to take that leap, the robots are working on what might be the ultimate scientific delivery. It's called Mars Sample Return. It is an unbelievably ambitious plan to go to Mars, pick up the rock samples that Perseverance is collecting right now, and bring them all the way home to Earth. For the very first time, we'll be able to study pristine pieces of Mars in the best laboratories in the world. So, this is where we are today. We are literally on the verge of having humans living and working on the moon again, while at the same time we're planning to bring back pieces of Mars that could answer the ultimate question: are we alone? It just leaves us with one final thought. In this incredible new era of exploration, what will be the defining discovery? What will we find?